Good afternoon, ladies and gentlemen. My name is Ansgar, and for the next 20 minutes, we are going to get to talk about my favorite thing to talk about in the entire universe, Saturn. Now, what is Saturn? Every great product begins with a problem, and Saturn is no different. The problem that beget Saturn is the problem of where is Web3 YouTube. Right now, we all, whether we admit it or not, know an uncomfortable truth. We cannot build YouTube-scale apps on Web3 infrastructure yet. Now, let's dive in. What is YouTube? YouTube is an enormous pile of hardware and software around the world built to do one thing: deliver content to you, in this case, video. And that is what Saturn is also built to do, to deliver content globally. To solve this problem, to let you, someone in this room, or someone else, build YouTube-scale apps in Web3. Now, Saturn is a decentralized, crypto-incentivized content delivery network. Let's tease those pieces apart and dive into each one quickly. What the hell is a content delivery network? Well, content delivery networks are actually pretty old. Saturn is not the first content delivery network. It'll be the best damn content delivery network, but it's not the first. The first content delivery networks actually came about at the turn of the millennium, 1999-2000, with a company you may have heard of called Akamai. And the problem Akamai set out to solve back then was you had the web coming online, and you had web servers, but users weren't always proximate to the web servers. You might have the web server in sunny, paradisiacal Palo Alto, California, and a user in Mumbai. And the website experience was slow, and more so when tons of users piled in and all tried to request content, the servers would melt. They couldn't keep up. They became unavailable. And content delivery networks were built to solve these two problems. So what is a content delivery network? They're servers and machines distributed all over the world to cache content. They don't store content permanently, instead they cache it temporarily, and the best way to think of them is they're kind of like Amazon in logistics. So Amazon has enormous warehouses in a few locations that store a plethora of variegated products, and then when products become popular in smaller subregions, those products are shipped from the enormous warehouses out to these smaller warehouses. And so when you order a product, you can get it quickly from a much smaller Amazon warehouse much closer to you. CDNs are those smaller warehouses. Now, the second piece, decentralized. What does decentralized mean? In the case of Saturn, what this means is Saturn is a permissionless, trustless network that anyone can jump in and participate in. There's no trust. Your dog can run a Saturn network node, and we'll get there in a second, and it's fully decentralized. We don't control it. I don't control it. No one really controls this thing. The software is what controls it. And the third piece is crypto incentivized. What does cryptographic incentives give us? Well, in Saturn, if you run a Saturn node and contribute bandwidth and storage to the network and be remunerated in return for your contributions, all of your remunerations and your contributions are guided by incentives that are tied to cryptography and cryptocurrency. So if you're a good node and you serve more content more quickly in a more available manner, rewards run to you. And if you're a bad node and a bad boy or bad girl and your node goes down or becomes overloaded or simply goes offline, your rewards can be slashed and the rewards run from you. So those are the three different pieces that comprise Saturn. Now, how the hell do you build something like this? Well, it turns out Saturn is live and roaring and running, and we'll get there in a second, but let's run through the general architecture of how you build a content delivery network like Saturn. So Saturn is comprised of three primary components. On the left here, in the orange box, is an application with a little magic slice called the Saturn client inside. And what the Saturn client is the client, like many others, like an HTTP client, and it's responsible for making requests to the Saturn network and retrieving or getting response back and then doing a bunch of other stuff, and we'll get to the stuff in a second. And in the middle, in the column with the blue boxes, those are Saturn nodes. And so what a Saturn node is it's a server somewhere in the world that we don't control. No one, like an individual owner operates that node. The Saturn team does not in a decentralized manner. And it's a cache, so it has a big disk and it's got a fat internet pipe and it sits there and caches content and serves that content. And these nodes are all over the world. And then the very bottom here, if we see this orchestrator and control plane box, this is the glue, the magic Elmer's glue that holds all the pieces together. This is the software that detects when a new node joins the network, that gives a new node a weight so it starts receiving requests, that sees how many requests a given node has, what is its performance, etc. It's the software which tailors the garden, like trims the weeds and lets the flowers bloom. And now, in this diagram, while still up on stage, we can see the overall end-to-end request flow. So if you have an application here on the left, and this could be a web browser, it could be an application on a server in Rust, it could be anything in between, it will make a request for a piece of content via its content identifier or a SID. So all content requested in Saturn is content addressed. And that request will land at a proximate nearby Saturn node that should be quick to respond with the content. But if that node does not have the content, its cache misses. And what that means is it looks in its pockets and says, well, shit, I don't got it. And it goes to IPFS or Filecoin, which are kind of the substrate below Saturn. So IPFS and Filecoin store the content, and Saturn is the cache on top. To run with the Amazon analogy before, IPFS and Filecoin are the big, fat, honking Amazon warehouses that store all the teddy bears and Barbie dolls, and the Saturn nodes are the smaller warehouses. So let's dive into these components individually. So over here on the left now, we've zoomed in on the application with the Saturn client they're in. And now the Saturn client does a bunch of magic to give you access to the Saturn network. One of the key pieces of this is smart node selection. So with Saturn, there are nodes all around the world, and there's a bunch of nodes close to you. And when you boot up and your application needs data, which nodes should you talk to? Which nodes will give you the data fastest? You're not exactly sure. So one of the responsibilities, the thing the smart client does that is so very smart, is it talks to a bunch of nodes nearby and actually gets real-world measurements. This server I can reach in 20 milliseconds, this one I can reach in 70, I should probably send more requests to the one closer to me. And it's always pruning and managing this list. The second thing it does is it verifies content. And this is the key that unlocks the trustless aspect of Saturn's network. Because anyone can run a node, you can't trust what content they serve from that node. I don't know how many kitty lovers are out here, how many puppy lovers are out here, but let's run with a kitty-puppy analogy. Let's say you're on a website and you want to load a picture of a cat, and you send that request to the nearest Saturn node. That Saturn node's like, kitties suck, dogs rule, and they get that request and they send you a picture of a dog instead. Well, as we'll get to in a second, the content that the node sends you can be verified. It's packed into what's known as a CAR file, a content addressable archive. And what a CAR file is this clever wrapper around a file which takes a file, breaks it into little blocks, hashes all the blocks, and then weaves all those hashes into a Merkle tree. And so when you request a cat image and you receive a dog image, you immediately can say, wait a second, the first hash in this Merkle tag does not match up with the SID, which is the root that I requested, which is the content identifier. And so the Saturn client can verify content. Now, of course, it's also robust. It can retry. If nodes send it the wrong content, verification fails, it'll talk to another node. If a request fails, it'll talk to another node. So there's a lot of robustness built into the client as well. And the last key responsibility of the Saturn client is it reports on the L1 nodes it talks to. It is the eyes of the Saturn network. Every time your client makes a request to the Saturn network, you are improving the Saturn network. You are providing data to the network saying, this node is slow, this node is great, this node passed verification, this node failed verification. Now, the second piece, the Saturn node itself, and this is the software that runs on servers that caches and distributes content. So its primary job is just sit there and fill up its disk and send as many bytes off that disk as it can to users. And again, what it sends is not regular files like cat.ping on your hard drive. What it sends are these content address archive files that can be incrementally verified by clients. And again, as we kind of talked about before, on the back end of the Saturn node, those two green dots were IPFS and Filecoin. It cache misses to IPFS and Filecoin and other sources in the future, custom origin servers and other places. And a key aspect of each Saturn node is it's based and ranked on its performance. So again, this gets back to the crypto incentives. If you have a fast, well-performing node, the rewards run to you. And all these reports from all the clients around the world all help you as a Saturn node operator earn those rewards. And the last piece here, of course, is Saturn nodes also report their own metrics, just like Saturn clients report metrics. Now, the last piece of the tripod, the orchestrator or control plane. This is the brain. This is the Nexus. If you're familiar with like X-Men, this is Cerebro with Captain Xavier in the helmet. This sees everything. And it monitors the network and responds to network conditions. When a node goes down, it's removed from the network. If a node becomes overloaded, too much traffic flowing, it's choking, you'll pull back the weight on the node to let it catch up. It has other responsibilities. It sets nodes' weights. It issues DNS and TLS certificates. So for nodes to be accessible by browsers, they have to have SSL or TLS certificates. It does a bunch of kind of administration work like that. And the last two pieces that are responsibilities of the orchestrator are, firstly, it's the part of the network that calculates rewards. Give me that gravy, baby. So when your node contributes a lot of bandwidth to the network and does so in a fast way, the orchestrator knows that, both from client reports and the node reports itself, and can calculate how many rewards you should be remunerated with. And finally, it's the policeman of the network, or the policewoman of the network, in the sense that there's no proof of retrievability. Insofar, you have to rely on these reports from the various pieces and the various actors of the network. And the orchestration layer, the control layer, is the one who says, this is anomalous, this looks like some sort of fraud or collusion or things like that, and will punish nodes for that. Now, what happens when you combine all three legs of this tripod and do my favorite thing in the world, which is ship software? Well, a year ago, 348 days ago, it was November 21st, 2022, we shipped Saturn. We launched Saturn and the Saturn network publicly, where anyone could go, download the software, and run a node. And that's a fateful day in my life. And since then, 348 days, we have grown explosively and ascendantly. 1 year ago, we had 0 nodes in the world. We now have over 2,200 as I speak. A year ago, 0 requests a day, now over 100 million requests a day. A year ago, you couldn't even fetch content. Now you can fetch content globally around the world with a median time to first byte latency of 65 milliseconds. All this in 1 year. Now, let me help you visualize that, because I hope you guys all have your seatbelts on. This is, by the way, is my favorite slide in the whole deck. I'm still trying to figure out where I tattoo this on my body. I'm thinking like forehead, something like that. But what we see here in this slide is the time to reach 25 terabits per second capacity in a network. Now, you may have heard of these other funky guys over here, Cloudflare and Fastly. On the left is Cloudflare. It took them 10 years since their inception to build a network that had 25 terabits per second of capacity. Fastly, 7 years. Saturn, 1 year. This is the gasoline that Saturn's cooking with. This is why Saturn will win. This is why Saturn's going to beat everybody else. Is this asymmetric warfare model where we, Saturn's engineers, go to sleep. You know, we tuck in late at night, we put our heads on our pillows, and nodes join the network. It gets bigger, it gets faster. While we sleep, the network grows and gets better, faster, cheaper. Now, what does this actually look like? Well, what we're looking at here is a screenshot of this morning, about 10 a.m., when I was putting the slide deck together. And we're seeing, zoomed in, a map of Europe and all the nodes they're on. So you can check out explorer.saturn.tech, and there is a 3D global visualization of all the Saturn nodes around the world, and here's we're zoomed into Europe. And so every little circle blip you see on the map is kind of a cluster of Saturn nodes, and the number inside of that blip is the number of nodes in that cluster. And again, if you were to rewind a year and look at this map, it'd be barren, a wasteland, 0 nodes. And in 1 year, that's what we've got, and we're just getting started. Now, you want to jump in. I understand you want to put your swimsuit on and let's go swim, let's jump in. So how can you get involved? Well, one of the things you can do is you can run a node. So what does that involve here? Well, if you have a server somewhere in the world or want to spin up a server somewhere, you can go get a Docker container, Docker compose, enter 2 environment variables, and you're off to the races. That's it. Your node is now running Saturn software, will join the network, announce itself, the orchestrator will add it, give it a TLS certificate, assign it DNS, give it a weight, and you'll start serving requests from real users around the world and being remunerated in Filecoin in return. Now, what are the requirements to run a node? 10 gigabits a second, minimum uplink, and 4 terabytes of SSD. And the more capacity you supply and provide to the network, the higher your earnings. So these are simply the minimum requirements. Now, something else, something that I'm very proud to announce, and all of you eager ears in the audience are the first to hear outside of the Saturn team. We're launching a private beta in 2 weeks. This is the first time that you, if you run a website, will be able to use Saturn's network. So what does this mean? If you run a website and you load content address content therein, if there are requests that your website makes to anywhere, an origin server, S3, whatnot, for SIDs, so for example, let's say you're an NFT marketplace or an NFT website, and you're loading pictures of NFT, metadata of NFTs, things like that, you, in 2 weeks, can add a Saturn Smart Client to your website, and then that Saturn Smart Client will run in all of your users' browsers. And automatically, all requests made for content address content are routed without you having to make any changes to your website otherwise, besides adding the client, to Saturn. All of your content address content loads faster. So we're launching this in 2 weeks. There's a QR code. And if you're interested in this, please come find me. I am not quiet, I'm not short, and I'm the most excited guy in here, so just come track me down. Now, what's coming up next? So a year ago, we had network launch. Now, in 2 weeks, we're going to be launching for the first time for users and customers. And along this growth trajectory, what's up next is kind of edge storage. And so again, as we talked about what a content delivery network is, it's caching. It doesn't store data permanently. Well, we've talked with a lot of users and a lot of customers and a lot of people, like many of you yourselves, want to store data at the edge as well, pin data at the edge close to users. That's what we're building and weaponizing the Saturn network to do next. And then beyond that, on our growth trajectory is edge compute, being able to run verifiable jobs at the edge on a bunch of Saturn nodes so you can run computation close to your users in a Web3 trustless manner. And the reason that all these things are plotted on a curve like this, again, it goes back to the gasoline Saturn is cooking with. All the while that we're building these things, the network is growing. And the market forces of the network, Saturn is like a marketplace where nodes join the network and compete. The price gets lower, the speed gets faster, the availability and performance improves. Now, questions time. So unfortunately, I'm the final boss between you and lunch. However, I know a lot of you guys are hungry, so I brought a little deliciously delectable treat. Unfortunately, there are no Saturn candy bars yet on the market. There will be, but instead I have Mars bars, another planetary bar. So if you ask a question, you have earned yourself one delectable Mars bar. And with that, I will open it up to questions. Thanks so much. So I can barely see, yeah, thanks.
Hi, Hi, so this is Hao from Block2Wallet, and I got 3 questions, mostly about the security stuff. So the first one is that you mentioned that Saturn client is able to verify the Merkle proof of the data. But I'm wondering where is the source of truth of the Merkle root? That's the first one.
Can you say the latter, pardon my interjection, can you say the latter half of that question again?
So where does the client get the source of truth of the Merkle root?
Great question.
And the second one is that the clients are also going to send reports to the layer 1 node you mentioned. So how do you prevent spam from that reporting? So these 2 questions about the clients. And the third one, and the last one is about the orchestration layer. So is this currently centralized, or is it like decentralized manner? Any specific mechanism introduced?
I feel like you deserve 3 Mars bars because all 3 of those are excellent questions. So you can remind me one at a time. Let's go back to the first question, which is how does the client know the source of truth for verifying the content? It's a great question. The answer is the client already has the SID. That's what it requests. So it doesn't request a URL like /path to cat.ping. It requests essentially a hash of the file, a content identifier. So if you've ever been in IPFS or Filecoin land and seen like QM ... this is what the content identifier is. So the client has to have that at first, but it has to have that anyhow because that's how it requests the content address content. And that SID is the root of that Merkle DAG. Does that answer your question? So essentially it has to have that SID ahead of time because that's the request that it makes. Now, next up, or let's tackle the last one first, the orchestrator in terms of being centralized. Yes, right now, we have been engineers with deadlines inside of Protocol Labs, and we have built the orchestration layer as components that are centralized. That is not the eventual plan at all. And I'm glad you asked that question, that the plan is to iteratively decentralize this over time. Is that right now, like I said, when Saturn first started to solve problems, or was first started to solve problems inside of Protocol Labs, we had to ship and we had to solve those problems as quickly as possible. And so we sat down and did, as we said, okay, here are the various components, and here's how we're going to build them, and here's how we're going to ship them as quickly as possible, ship early, ship often, and here's how we're going to iteratively decentralize these over time. So along that graph that you saw before is what we're going to be doing is decentralizing this control plane over time. And that's hard. Don't get me wrong, that's very hard. To do that in a global manner where, you know, the network in very kind of globally local regions, dare I say, can kind of network and police itself and have that in a scale. That's hard. That's definitely hard. But there's some great technologies coming down the pipeline as well, like IPC coming out of interplanetary consensus protocol coming out of Protocol Labs. This is something that Saturn is kind of waiting, chomping its teeth at the bit to come out, so it is a tool to help us kind of build and decentralize the orchestrator. And then if you don't mind, remind me the second question, which was the middle of your great question sandwich. You don't remember either?
Yeah.
Client spamming, yes, great question. Yeah, so the anti-fraud aspects and the anomaly detection aspects of this network is another key linchpin of the network. There is no proof of retrievability. We can't say one client and one server didn't collude over and over and over again. There's no proof of that. So one of the other models we looked at all the way back in the beginning of Saturn was, what's a model where the client would actually pay? The client would have a wallet and it would have to pay the node operator. And this gets around this kind of collusion problem where there's a log spam problem because it costs the client something every time it fetches content. The problem with this model is that it runs into a brick wall of just where the CDN industry is now. Who pays YouTube's bills? I guess we do by looking at ads, but YouTube pays YouTube's bills, when a company adds a CDN to accelerate its content, the company's the one who pays, not its users. You don't have to put a penny in the machine every time you use YouTube, that kind of thing. And so we built Saturn in that same way so that we could go and conquer the Web2 market as well. And that puts us in the land of we have to do anomaly detection and fraud detection and deal with spam and things like that. So here's the analogy I liken it to, and I think is an apt and a positive analogy. Google runs a bunch of ads, and it can do nothing to stop ad fraud and ad click fraud. There's nothing that stops you from going to your own website and just clicking on your ad over and over, besides Google sending a henchman and beating you with a truncheon or something like that. That's not something they can obviate against. However, that has not stopped Google from building the world's largest ad network and becoming, an absolute world player in ads, the dominant player in ads. They've built software which does this, which detects frauds, fends against fraud, and Saturn is going to play this. They have to play the same game until users start paying. But that's the eventual goal that we'd like to get to, is having users pay, because it gets us out of all these problems. But this is not the way the world is now. It's going to take time to kind of push that model. Does that answer your question? It's a great question. And you got 3 Mars bars waiting for you for dessert, brother. Oh, yeah. There you go, man. Thank you. Oh, yeah.
I'm actually on the Saturn team. I just wanted to add one more thing, which is that although you need to know the content identifier, the trees that we use are actually a little bit smarter than Merkle trees. They can encode entire file directory structures. So if you have an images folder in your website, you can hash all that down to a content identifier and then be content identifier / cat.png, which is pretty cool. You can basically, get full directory semantics after the content identifier, and it's all still verifiable, and it won't send you the whole thing. We've got ways to do that too.
Thanks, Hannah. And everybody, that's Hannah, and she wrote enormous pieces of all of Protocol Labs and IPFS infrastructure. So thank you, Hannah. Okay, another question? Again, I can barely see you guys. I'm staring into the 6 suns up here.
Hey, hi, excellent presentation. I have a quick question, actually 2. In the difference between Web2 CDN and Web3 CDN, I suppose you're relying on normal users to run your nodes, so it becomes a dynamic network and anyone can leave at any point of time. So I understand you put slashing conditions to prevent that, but how does that actually affect the data, reliability and the time it takes to actually retrieve data? That's the first one. And second one, why do you call it Saturn?
That's a great question. I'll let you guys in on a little secret. There were 2 names at the very beginning of Saturn. When Saturn was first born and came into this world, it could have been christened one of 2 things, Saturn and Beam, and Saturn happened to win out. I can't say there's any story where there was a loving mother looked over the child and said, you are Saturn and not Beam, but those are the 2 competing names, and Saturn ended up winning out. And it plays into the interplanetary motif and meme, and it lets me hand out Mars bars for questions, things like that. So it's a great name. And now, your first question was on nodes joining the network and trust. Would you mind repeating that?
Sorry. Yeah, slashing is one way as a post corrective thing, but like just how to ensure your data availability, reliability, and the times in which you can fetch data.
I see. So the thrust of the question, if I may paraphrase to help myself understand, is slashing is retroactive. How do you prevent abuse before? Is that kind of the thrust? Yeah, great question. Great question. The answer is, it goes back to the smart client and the responsibilities of the smart client, where one of the things the smart client does is it verifies all the content it receives. So it does this incrementally in real time. So if some node tried to send it incorrect data, either through malice or accident, the node can detect this and go to a different node. And that's the robustness and the key aspect of the Saturn client. The Saturn client forfends the parent application from a bunch of abuse of the network, if that makes sense. Does that answer your question? No. Not retroactive. As the file is received by the Saturn client, it's incrementally verifying piece by piece by piece and the hashes of those pieces to see if that content that it requested matches, to see that the content that it received matches the SID that it requested. And that happens in the request process, in the request response process. If I didn't answer your question, please find me afterwards. That's a great question. Great question. Any other questions?
Hey, yeah, here.
No idea where you are. Thank you.
I'm Pablo from Edge and Node.
Yeah.
You hinted at payments in a previous answer. I was wondering, how do those payments happen? Do they go through the orchestrator? Do they happen on chain?
That's a great question. So the way the payouts currently work is the payouts are calculated by that control plane, and then they're dispersed through smart contracts on FVM. So if you run a node, that you can claim your earnings from a smart contract where your earnings are delivered. But it's the orchestration layer that kind of calculates that right now. And in the future, we'd love all those calculations to happen like on-chain in a more verifiable manner.
Sorry, I mean, as a customer, if I want to pay for this, does that happen in the same way through that orchestration layer?
It will soon. Okay. It will soon. Not
Thank
yet,
you.
but it will soon. Exactly. You in the short future, in the near future, you'll be able to, as a customer, enlist Saturn and bring the weapon that is Saturn's network to bear to accelerate your content and pay for it in crypto and in Filecoin, all through smart contracts. Absolutely. Not there yet. Soon. Another question.
Just asking regarding the payment from the users, can we not make people pay for this streaming from Saturn through their attention, which is how it is monetized on Google and everybody else? So we need to maybe build a system that automatically they monetize their attention, their time, or any other way monetizing their own data.
That's a great question and a sage question. One of the origins also of Saturn is how can we get clients to act like little cryptographic wallets and actors in the network, such, for example, that they can pay with a cryptocurrency. So you could, as like my little analogy, putting a penny in YouTube every time you use it, except that's a crypto penny instead. So we've thought about building a browser client that has a little cryptocurrency wallet in it, and perhaps it could either be airdrop some cryptocurrency initially so it can get started, because otherwise if you just have a browser client with an empty wallet, you can't load any content from Saturn. But also you'd be able to kind of pay with your attention, kind of like BAT with Brave, or even potentially mining. You as a browser could share content back with the network in some way by uploading content that appears near you, for example over WebRTC, and earn cryptocurrency to accumulate in your wallet with which you spend to navigate other websites. So we thought about that, and that's absolutely a direction that, yeah, we would love to explore further. We didn't go that approach initially because we just want to ship like absolute fucking crazy, and that's a more complicated option to get started with. So it's something that kind of is not on the back burner. It's in our minds, burning in our minds, burning like a coal out of a fire in the flesh of our mind, if you will. We're always thinking about it, but it's not something we're building yet, not something we've built quite yet. Does that answer your question? It's a great question. An absolute Mars bar worthy question, 100%. Any other questions? Close it out. All right, I'm closing the bar down, guys. Thanks. Thanks, everybody, and have a good one.